Hello students, today I will show you how to calculate some of the moment problem in physics. Before we start solving the problems, we will discuss about the two formulas that we use during the calculation. That is, we know moment equal to force multiply perpendicular distance from the pivot. That means the line of the action of force, the pivot point, that is when we need to calculate the moment of something, we use force and the perpendicular from the point of action of the force and the perpendicular distance from the point of action of the force. And another formula, that is the principle of moment, that is sum of clockwise moment equal to sum of anti-clockwise moment. Okay, sum of clockwise moment equal to sum of anti-clockwise moment. Anti-clockwise moment means this direction and clockwise moment means this direction. Okay, in the clockwise rotation, and this is anti-clockwise rotation. Okay, let's see how to solve out the problems. Now we need to find the value of x. Here a pivot point is given, line is given, a rod is given, and the pivot is stand from 2 meter from A and 3 meter from B. B has a force of 200 Newton. B have a mass of 200 Newton. B has a force of 200 Newton and x is unknown. X Newton is unknown. So by calculating the moment, we will find out the value of x. So we know moment equal to force into perpendicular distance from the pivot, and the law of conservation of moment is sum of clockwise moment equal to sum of anti-clockwise moment. Here the force and unknown, the distance and unknown force is given in this direction, and the force and known distance is given in this direction. So make an imagination that if you pull an object with this force, it will rotate in a clockwise rotation, right? This will rotate in a clockwise rotation. So find out the moment of a clockwise rotation first, that is moment clockwise equal to CW moment. You can write here clockwise moment, that is 3 multiply 200, which is 600 Newton meter. Okay, so you have already seen that the clockwise moment is 600 Newton meter. As you know that the clockwise moment will be equal to the anti-clockwise moment, so the moment in this direction will be also 600 Newton meter. The moment because if you pull the force in this direction, this is a anti-clockwise rotation, and the moment in this part is also 600. Why 600? Because the sum of clockwise moment will be equal to sum of anti-clockwise moment. So using 600, you'll write the distance is given and x, this is unknown. X, this is unknown. So 600 divide by 2 equal to x. 600 equal to 2 multiply x, and 600 divide by 2, that is the value of x, that is x equal to 300 Newton. That means the value of x is 300. Why 300? Because if you pull the value of x with 300 with a distance of 2 meter from the pivot, the moments are same in both the sides. Okay, now this is another question, that is a rock is given with a 6 Newton force, another rock is given with a 4 Newton force, and this x is unknown here. This x is unknown here. Okay, you can imagine that from the pivot line this x is acting at a 4 meter distance. This force is acting at a 4 meter distance. Why 4 meter distance? Because 2 meter and 2 meter, that is 4 meter distance from the pivot point. This x is acting from 4 meter distance from the pivot, and this force is acting at a distance of 4 meter from the pivot. So this force and this force will make the rod move in clockwise direction. If you turn the force like this, it will rotate this way. If you turn the force this, it will also rotate this way. So both the force are responsible for clockwise rotation. Okay, both the force are responsible for clockwise rotation, and this is the only force that will turn into anti-clockwise rotation. This is the only force that will turn the rod into anti-clockwise rotation, and both these force will make the rod move into clockwise rotation. Are you clear? Okay, now let's see the clockwise first. That means force into distance, that is F into D plus F1 D1 equal to F2 multiply D2. And why F1 D1? Because this is force 1, this is distance 1, and this is force 2, this is distance 2. Okay, and this is F2 and D2, and here only one force is acting with a distance of 2 meter, so you'll write here only force into distance. Okay, the first force is 4 Newton multiply 4 meter plus the second force is x multiplied by distance of 4 meter. Okay, and the force here is 6 Newton force. This is, it's acting at a distance of 2 meter. 16 plus x4 equal to 12. Okay, 16 plus x4 equal to 12. Okay, now if you cut this like 4x equal to 12 minus 16, so 4x equal to minus 4, that is x equal to minus 4 divided by 4, which is x equal to minus 1. So minus 1, that means only force 1 Newton is the extra force that will be needed to make the rotation clockwise. This is the only force that is needed for don't bother about the minus, because minus 1 is the direction of the upward. Minus 1 is the direction of the upward force, because this is acting upward and this is acting downward. Okay, the directions are not the same, so minus 1 will be in this direction. Okay, so only 1 Newton is the force. 1 Newton is the force. Minus 1 Newton is the only extra force needed to make it a balanced one. Okay, so x equal to minus 1. I hope you are clear with the video. If you have any problem, please let me know on the comment section.